Section 14.8, acid-base titration. This is a neutralization reaction, so that third type of reaction that I talked about in the last video. Anytime you take an acid and react it with a base, it's called a neutralization reaction because it's getting closer and closer to neutral. All right. Now, a titration is a special procedure that's typically used to determine the molarity of a solution. So in other words, like let's say I've got this bottle, right? Ooh, look at my skills. I got this bottle, and this bottle is an unknown acid. I don't know what the molarity is. So what I can do is I can use this burette, right? And I can drip sodium hydroxide into that. And because I know what the reaction is, I can figure out the molarity of this. All right? So that's what a titration is going to do. You're going to do these in the lab. You'll do them a lot. So, like I said, we take a known volume of acid and we place it into a flask. So that's right there. All right? We don't know what the molarity is, but we know how much of it we have. We then put an acid-base indicator into the acid. In this case, we're going to use phenolphthalein, but there's all sorts of different indicators that you can look at. And what an indicator does is it changes pH, or pardon me, it changes color at a very specific pH range. Right? So the indicator usually works at plus or minus pH of 1. So in other words, it'll change it at a pH of, let's say, 3.8. So from 2.8 to 4.8, that acid-base indicator works. You can use that acid-base indicator. What we're going to use is phenolphthalein, which I think has a pH, a pKa of like I want to say 8 point something, but I'm not entirely positive. But it works from anywhere from 7 to 9 point something. All right, for phenolphthalein. Now, when that indicator actually changes color, we call that the end point. All right, so when the indicator changes color, that's the end point of the indicator. So in this case, right down here, you can see this phenolphthalein is pink. Well, that's because we've reached its end point. We've reached the point which it changes color. Okay. Now, we want the end point and the equivalence point to be at the same time. So let me write that down. We want the end point, which is when the acid-base indicator changes color. We want the end point and the equivalence point to occur at the same time. All right. So what's the equivalence point? The equivalence point is when all of the hydrogen ions react with all of the hydroxides. Right. Now that's the appropriate way to say it. The wrong way to say it is when all the acid reacts with all the base. The best way to say it is when all the hydrogen ion reacts with all the hydroxide. Right. Now, if that's true, the moles of hydrogen ion and the moles of hydroxide are going to be equal. Now, that doesn't mean the moles of acid and the moles of base are equal. We're talking about hydrogen and hydroxide here. And again, we want the equivalence point and the end point to be the same, because what we want to happen is we want this to change color right when we know that all of the hydrogen ion equals all the hydroxide ion. Because if all the hydroxide ion, which is something we know, equals all the hydrogen ion, then I know how much hydrogen ion I have. And I have solved this molarity problem because I know how many hydrogen ions I have in that amount of space. Now, anytime you have equivalence, okay, anytime you have equivalence, you can use this reaction or this equation. All right, that's molarity of the acid, volume of the acid, number of hydrogen ions. Let me give you an example here for number of hydrogen ions, what we're talking about. HCl would have 1 because it has 1 hydrogen ion. H3PO4 would have 3 because it has 3 hydrogen ions. Okay. Now these are ionizable hydrogen ions. So like HC2H3O2, that still only has 1 hydrogen ion. That's ionizable. Okay. Molarity of the base, volume of the base, number of hydroxides work the same way. So if I have something like calcium hydroxide, CaOH2, that number of hydroxide would be 2. Okay. And so from this, you can figure out the molarity of the acid, you can figure out the volume of the acid, you can figure out the molarity of the base, you can figure out the volume of the base. You can figure out any of those things. Okay, and again, that can only be used for equivalence, and you'll see that when you look at the video problems 90 and 91.